So we talked about this already, where we have converting from a fraction to a decimal, which means you have a fraction right here. And then when we said before last time, we have a fraction like 3 over 4. The 4 is the one that's dividing into. So we rewrite it as a division problem. The 4 is on the outside, the 3 is on the inside. The most common thing I see that goes wrong if people do this. No. One of those days. It's Monday. This is the thing about these from home. It cracks me up. But last year, I described classes from home. Sometimes people didn't show up, so I recorded them anyway. I'm sitting in a room by myself, cracking up my own jokes, right? It's really sad. I'm just laughing at my own jokes. Like, this is really sad. So anyway, so at least there's people here to laugh at my stupid jokes this time. So remember what we used to do? We said 4 cannot go into 3. So we put an extra 0 in. And 4 goes into 30, 28 times. And we put the 7 over 3, sorry, over 0, and then we subtract and work it out. Converting that decimal to a fraction, remember what we did? We used to use our decimal places, and there's 2 decimal places. The first one is tens, the second one is hundreds, and we place 2 over 100, and then we reduce. Down here. Proper fraction to a ratio, or ratio to proper fraction. Remember what we said? This is not too bad. The first number here goes on the top number goes in front, the bottom number goes in the back. Or in other words, the first number goes on the top, and the second number goes on the bottom. Nailed it. Then what we said, finally, we said this. Mixed number ratio and ratio to mixed number. So we had this ratio looks like this. We had 4 in the bottom, a 1 and a 3. And the book writes it out like this. I'm very visual, so when I see something like that, I have 1 and 3 over 4. I go counterclockwise. 4 times 1. And add 3. That becomes 7 over 4. It's funny about that, like me in terms of visual things. My passwords, I don't remember the actual password. I remember the key punching symbol, how it fits on a key punch. So if you give me a keypad or a different kind of or a straight line key, I'm messed up. So like when I'm typing my password on the keyboard, with a keyboard like this, with a keypad like that, or like my cell phone, fine. Keep my laptop with all the keys just numbers in one row, forget it. I'm like, you know what? I'll try later. Someday I'll get better at it. All right, decimal to a percent. Move the decimal places. So if it's a decimal, 2%, move the decimal places 2 places to the left. If it's a percent to a decimal, move the decimal places 2 places to the right. So 5 becomes 0.05, and 0.25 becomes 25. That was easy, not a problem. And fraction to a percent, basically you just divide it through and multiply by 100, and decimal to ratio, convert to fraction, and change it into a sign with a colon. And that's that for that. Let's have some practice. What I want to do this time, I want to let you try some of these yourself first. Take a second and fill in the blank. See there's something there? First one says the decimal is 0.05. What is it as a fraction? What is it as a ratio? What is it as a percent? Actually, I think I gave you the answer. With this gives you the answer to everything. Let's try one. Let's try an example that doesn't do that. Back to here. Let's do a practice one. There we go. This one we're looking for here. All right, let's try this practice stuff. Try this. We have 5/8, rated as a decimal, a ratio, and a percent. I'll give you guys a head start. Try it out. Go. Try this one out here. Number one, try it out. 5/8. That's a fraction. Take the fraction, make it into a decimal, turn it into a ratio, and then a percent. Not necessarily in that order, because what I would do first with that one there, I'd do the easiest one. I'd do this one here first. I would go, as a ratio, it's going to be 5 to 8. Awesome. So, converting it into a decimal, looks like this. This is number one. You have the 8. We'll divide into the 5. Remember the one on the bottom was on the outside? And 8 cannot go into 5. So we need a 0. So put a 0 here. And put a decimal right here. So 8 goes into 50 how many times? Remember our gazintas. Gazintas. 8 goes into 50. 6 8s are 48. Right on. 48. And then we subtract, and we have 2. And 8 does not go into 2, so we need another 0. And the 0 pops straight down. And it turns up down here in the wrong color. Can 8 divide into 20 evenly? 2 times. And that gives us 16. And if we subtract that, we get 4. And we need another 0. And the 0 comes here. Can 8 divide into 40? How many times? Exactly right. 5 8s are 40, which is pretty easy because we know 6 8s are 48. So 5 8s must be 8 less than 6 8s. Who knew that was ever possible? 40 and subtracting, and we get 0 remainder, which is perfect. So our decimal is 0.625. And how would it be? Sorry? That's right. I'm the bad boy by 100. And that simply moves the decimal places, 2 places to the right, 62.5%. Question number 2. The ratio is 3 to 25. The easiest thing I would do first is come over here and go, the 3 goes on the top, and 25 on the bottom. Nice. Turning that into a percent, or sorry, a decimal. Okay, I'll take your word for that. I'm cheating now. But since I legalized cheating, this is not cheating anymore. I love being in charge. I can legalize anything. I can Trudeau can legalize marijuana, I can legalize cheating. There you go. Don't tell me I said that. Although it's recorded for the internet now. Thank you for that. Sometimes I get myself in so much trouble that way. I'm just thinking myself. Hang on a second. Gotta pause this. So dividing by 25, we have the question of 3 divided by 25. And I get 0.12. Oh, let's try it. Is that right? Try it again. 3 divided by 25. 0.12. Let's do it by. I know. I was just like, you know, that's one of those things you don't believe what you're reading. It's Monday. Having a great day. That's why I come to class. It's so much fun. Okay, so let's do this by the long way. 25. Gazinta. This is number 2. This is the longest question I ever written in my own life. I can do calculus faster than this. Dividing into 3. And 25 will not divide into 3, but let's put a 0 here. There we go. Put a decimal up here. And 25 will go into 30. Yes, it will. 1 time. Oh, my bad. Thank you for that. Funny. All right, so 1 times 25 is 25. Then I subtract 25 from 30, gives us 5. I need another 0. That drops down. 50, and we know that 25 will divide into 50 2 times. Subtracting gives us 0. So as a decimal, it now becomes 0.12. And as a percent, multiplying by 100, it becomes 12%. Let's do the next 3, take a little break. Then we'll finish chapter 6. I thought I had chapter 6 done by now, but I guess I'm not halfway through yet, so let's get this part done. Okay, as a decimal, as a percent, the next one is 0.25%, so let's just jump right into a decimal, because divide by 100, the decimal will be 0.25. Yep. And reducing would be? Okay. Here's a little trick I always use for this for 25s and hundreds. 25s and hundreds. How many pennies in a dollar? 100. How many quarters in a dollar? How many 25s in 100? So 0.25 is one out of 4. So 1 quarter out of 100 is 0.25 or 25. Perfect sense. Quarter of a cup. So that's just 1 point. That's 1 over 4 in that point. Then the ratio becomes 1 to 4. That one was a lot easier. Thank you very much. I'm here all week. It wasn't too painful. So this one here is a decimal. It's 0.375. As a percent, it's going to be 37. As a fraction, what's it going to be as a fraction? Oh no. Or we could just do this. Tens, hundreds, thousands, right? And then reducing. Oh, let's try 25. So 25 from the top is 15. And 25 from the bottom. I just made it up. No. Where it came from is when I see the 75 right here, I know that 75 is multiple of 25. So I know that 300 is a multiple of 25. And 75 is also a multiple of 25. So in 25 we went to 375. That's where it comes from. But I could have used, obviously I could have used a bigger number because this here can still be reduced. All right. Yes, that's correct. Awesome. So that becomes fraction 3 over 8. And the ratio would be 3 to 8, yep. The last one, thank goodness. 125 as a fraction would be 1 over 250. I don't know. It's 250. Oops. That sounds about right. Okay. Just losing it today. 250. It's funny how it starts out in my head as 215, comes out differently in my hand. Into 1. So we need a 0 and a decimal up here. So 25 will knock into 10, 0, another 0. Knock into 100, 0. Need another 0. 25 into 1,000, sure goes. And I think someone said it, 4, which is 1,000. And subtracting, we get 0. And coming back up here, we have decimal 004, 0.004, and over here we have 0.4%. All right, let's do some more examples from the book. Those seem to be going pretty good. Let's see what else we have to do. Combine applications in measurement. I talked to you guys about the old English system, right? About the inches and feet and all that stuff, where it came from. I gave it a little presentation, didn't I? An inch is the size of my thumb. Okay, good. So we have height measured in inches and feet and meters and centimeters, weight, pounds and ounces, kilograms, and so on. So these are just basically common measurements here. Ones you might not be used to seeing, though, right here is drop, and the symbol for drop is GTT. That's a nursing thing. And there's teaspoon and tablespoon. Wine cup. I'm not going to give you any questions like this about the word for FT. If you have trouble with that, look it up. Because cheating is allowed. I love being, what's it, a dictatorship. And we have time, weight, linear measure. These things here, these are all your equivalent statements. For example, 1 tablespoon is 3 teaspoons. 1 cup is 8 ounces, and so on. So if you want to, and you're really bored and like you have nothing to do and you have no life, you can memorize them. But if you do have a life and something better to do, don't bother, because I'll give you the answers.
I don't know if I got a life, but that's better to do.
Yeah, if you have nothing better to do than sit down and memorize conversion factors, you really got to get out more. I'm just saying. So we've gone through some of these. I'm going to do a couple of examples. The book actually sets it up like they did before in the ratio, but I want to do these examples using dimensional analysis, which will be very useful for those of you who are doing chemistry. You guys, hey, chemistry is awesome. Did you blow stuff up yet?
We're doing electron variance now.
No. All right, so let's look at this one here. How about we do number 5?
I noticed with the headphones there's a slight time delay.
Because it goes here, goes after satellite and back to you. But if you weren't sitting in the classroom, it'd be perfect. So number 5 looks like this. So looking at this through the chemistry eyes, converting 90 millimeters into ounces, let's look at it this way. I want to set it up like this. I want to start with 90 milliliters, so 90 mil. And over here, I want to end up with my answer in ounces. So coming back to our charts here, in our book, let's go back up and see if there's a connection between milligrams, milliliters, and ounces. And lucky enough there is. Right here you'll notice that one fluid ounce is 30 mils. One fluid ounce is 30 mils. So what that means right here, 1 ounce equal to 30 mils. I want the mils to cancel, so I'm going to multiply. I want to set this here up with 30 at the bottom. So when I set it up like this, it's going to be 1 ounce over 30 mils. If you want to see the actual calculation, it's going to look like this. $90 times 1 mil ounce divided by 30 mils. When you set it up like that, you'll see easily the mils will cancel. And 30 is 90, 3 times. And we have 3 ounces. And it's exactly a unit that we wanted to end up with. Make sense? All right, I'll post this to anyway. I'll try to get it done this afternoon. Yeah, see you Wednesday.
site I changed from medical technician to recreational therapist, so I won't be killing anybody with my bad now.
Ah, that's good to know. So the last section here talks about combined applications. It looks like things like from cups to mills. So let's look at one of those. Let's look at this one here. "28 inches into millimeters." Oh no! Is there a connection between millimeters and inches? Look at our little sheet back here, and we'll find out. We have inches and centimeters. Oh no, they're stuck. Can't do it. Is there a way to do it? Well, let's look at this one here. 1 inch is 2.54 centimeters. Is there a connection between centimeters and millimeters? Anybody know? Chemistry people should know this by now. The connection between centimeters and millimeters. Oh no. Okay. Yeah. What's the connection between centimeters and milliliters? Centimeters and millimeters. You got me seeing liters now. Yep. Perfect. So the other connection is 1 centimeter. In case you didn't know that, check this out.
Well, digital work.
On the top of this ruler, you can see we have centimeters. The bottom is inches. So you can see clearly now that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 millimeters in 1 centimeter. Thank you. So now we got 2 conversion factors for 1 question. What the?
So is that where you set up your cross
You could, or you could do it the chemistry way, which is even better. I'm trying to get you into thinking that way, because that's why I'm doing that. Because when I first saw this in chemistry books, it scared the hell out of me. And I was like, what the hell's going on with this? So, what I mean here, the answer needs to be in millimeters. So over here, the answer is millimeters. I'm going to get there somehow. But I'm starting with inches. I have two connections here, 1 inch in centimeters and mils. Those are my connections. So I know my end point. I know my starting point. I got to get there. So I have 28 inches. I want the inches to cancel. So I'm going to use this relationship up here. And I'm going to put the inches on the bottom. I'll multiply. 2.54. Centimeters will go on top. Inches on the bottom. What that means in chemistry world, the inches, or any world anyway, but chemistry specifically, I hate that word. Specifically, I can't say that damn word. I don't know. I mean, I've taught chemistry for I don't know how long, and there's one section in chemistry called specific heat. And man, it's the hardest chapter I can say. I can say spaghetti, but I can't say. Yeah, exactly. It just doesn't work for me. I just give up on it. So now the next one, I'm moving right along. I'm going to want centimeters to cancel. So I'm going to set up my next connection so that centimeters are on the bottom. And you'll notice that way the centimeters will cancel. And the units I'm left with happen to be millimeters. So, how do we make this number work now? How do we do the calculation? Oh no. There's an easy way to do this. I would recommend you watch this trick because you're going to die in chemistry class if you don't. Because you're going to go from, it's the same situation in chemistry class, but you're going to be going from grams to moles to grams in stoichiometry next semester. So you'll be using this technique 3 times in one question. So it'd be good to know how to do it. So what you do, the easiest way around it, the numbers on the top, multiply, on the bottom, divide. Multiply. So I'm solving this question right here. Very easy to do. All the big numbers, the ones are on the bottom, so there's no division at all. All I got to do is get 28 multiplied by 2.54 times 10. 711.2. And the units are left in millimeters, which is what we're looking for. The chances are we're correct. This is such a powerful tool that if you don't know how to get the answer, you can find the answer by manipulating the equivalence pieces and the units. I showed my daughter that trick when she was at St. Mary's. Doing chemistry down there. We had a question from our teacher. She didn't know how to do it. So what we did, we just started, this is our starting unit. We need to know our end unit. We just put the pieces in the middle and worked it out. Pretty easy to do. If you know how to do this stuff. So it's kind of important. So, coming back to the chapter, that's it for this chapter. We already did conversions as well. That's the final question on conversions. Done. Oh, I know, right?
So the assignment that is online, is that going to be what the test is on Wednesday?
Yep. Chapter 5. And then chapter 6, I'll just open the test up. You can do it anytime before the 13th. And then next, yeah. So it's a review test anyway. You should know how to do it. And then Wednesday, I'll do test on chapter 5 this Wednesday. And next Wednesday, chapter 7. Chapter 6, do it at home whenever you feel like doing it at home. As long as it's done by the 13th. Yeah, if you want to. Chapter 7, Pre-Algebra Basics. Algebra. Basic terms of algebra are numbers like integer, number statement, expression, coefficient, two bad words. They have positive numbers, they have negative numbers. Positive numbers, you recognize those because they're always generally happy. The negative numbers are just always in a bad mood. Everything's half empty for those guys. Stay away from negative numbers. They bring you down. Especially in the bank account, right? What do you mean I have the money left? I still got checks. Exactly, right. There is something called order of operations. It means rules. I hate rules. And word problems. Well, sorry? Yeah. BEDMAS. Yay. But I'll make it easy. Pretest, not doing that. I like making the rules. All right, let's look at integers. I will not ask you what an integer is because I don't really care. So, integers. Integers are basically just counting numbers. 1, 2, 3, 4 are integers. But the thing about integers is they go in both directions. Oh no. That's what makes them nasty. And the rest side over here, this we have the positive integers. These are the happy guys. Everything's happy with those guys. We have the negative integers. They're just angry all the time. Negative. Just bad news. Don't talk to them because they don't want to talk to you. Just saying. So if you're on this side, you're happy, positive integers. Other side, just don't go over there. They treat you bad. They push you down, take your lunch money. They do all kinds of nasty things to you over there. And you even have a sign in front. They come with a warning sign. It's the warning sign, and it's called the negative sign for negative numbers. Who knew? One more little discussion about how about negative numbers. Unlike positive numbers. Positive numbers are easy because it's like, it's always easy to say that 6 is greater or larger than 3. So 6 is a larger number. Negative numbers, not so much. It's the exact opposite. Of course, it's going to be the opposite because they're negative. They hate each other. So it means that 6 on the negative side is way less than 3 on the negative side. And don't believe me, think about owing your friend $6 compared to owing them $3. You know, 6 is way worse. So that's how negatives work. Where each is a negative integer. I'm not going to do that. Nothing. Let's try this stuff here for a second. All right, who's the person here that can tell me what these mean? What's this mean? This mean? Or this mean? Right. I don't know. I don't care either. All is what Kathy said is what I know. That's all I know. I can tell which one was less than which one's greater than, and it doesn't matter because I just do this, right? Remember the old Pac-Man day? Pac-Man, like this. I just draw the head on it. My Pac-Man is kind of ferocious because it has teeth and it's shark eyes. And it's nasty, but it's going to bite the larger number. And that's all I got to worry about. So I used to get out when I was in school. This used to freak me out. Which way is the point? This way or this way? I don't get it. But then I thought, but the Pac-Man guy, never forgot it after that. Because it doesn't matter which one's greater than or less than, as long as it bites the larger number. So now looking down here is plus 6 greater than negative 6? So it's going to go this way. Which negative 4 and negative 2, what's the relationship? Negative 2 is bigger. So if I was reading that, now that I know which one is which, if I was reading that, I would say plus 6 is greater than negative 6. Minus 4 is less than minus 2. But before I put the Pac-Man thing there, squishy head, squishy, I wouldn't know. Whatever. It doesn't really matter. Which one's bigger here, 12 or 16? 12. Oops. Go away. 12. Larger. Down here? Equal. How about down here? Tricky. Plus 24 minus 24. All right. All right, so now we got that figured out. That's awesome. Absolute value. I got one thing to say about absolute value. No, two things to say about absolute value. Don't read your book. Don't go there, because that's motion pain. So the big thing to think about absolute value is this. Absolute value is always positive. They will define it as the distance from 0 to that number on the axis, left to right. And they would define it as the distance because distance is always measured positively, not negatively. You can't have negative distance. Try walking backwards, still going positive behind you. But, mess with your mind. Just think about that. Don't think about what I say. Just think about what I say. It's kind of like never say never. Yeah, so, but just think about it. If you just think it's always positive, you won't have a problem. For example, before we do the most common problem, let's do what it means. So if I have, let's say I have 7. The absolute value of 7 is 7. If I have negative 7, absolute value is still 7. All right? Common mistake would be, people would say the absolute value of 7 is negative 7, and the absolute value of negative 7 is 7. Don't do that. It's just always positive. But that's what I'm saying. The most common mistake is people do that. People just switch the signs all the time. If I said to you with negative absolute value of 7, they say negative 7. But it's still 7. It's just a trick. It's just a trick. Still 7. I don't know, but that's what happens all the time. So I'm trying to prevent you from doing that. All right, so its time is up. So we'll pause there.